Hello and welcome to this training video about administering virtual networking. In the part 1 of this video, I talked about the virtual networks, subnets, and the IP addresses. In this part, I will talk about the network security groups, why shall we care about them, and how to implement the network security groups in Microsoft Azure Cloud. My name is Navneet Kumar. I'm a Microsoft certified trainer. The learning objectives of this module are implementing the network security groups, determining the NSG rules, determine NSG effective rules, create the NSG rules, implementing the application security groups, finally, the demonstration about the network security groups, and a learning recap. This module is part of the learning path which is implementing and managing virtual networking that covers 15 to 20% area of the AZ-104 exam for Azure administrators. This module covers creating and configuring network security groups and application security groups. Also, evaluate the effective security rules in the network security groups. First thing first, let's talk about what is network security group. The network security groups are the access control list that are used to control the inbound or outbound traffic. We can create and associate these network security groups on the subnets or the individual VM NIC. These network security groups have the inbound and outbound rules like our Windows firewalls we have, through which we can control the incoming or outgoing traffic of the virtual network. This limits the network traffic to resources in a virtual network, and it's a security service. Lists the security rules that allow or deny the inbound or outbound network traffic. It is associated either at the subnet level or network interface card, or we can implement it on both resources, the two different network security groups, for defense in depth, so that we can protect the entire subnet by putting a NSG at the subnet level and individual NIC of the server by putting a network security group on the NIC of that machine. It can be associated multiple times. One network security group can be associated with multiple resources as well. Well, this is about the network security group. What network security group is, you can think of it as a firewall which controls the inbound and outbound traffic. But in terms of firewall, do not get confused with this as the firewall that allows the IP forwarding or can do the SNET or DNET. It is literally the access control list. In fact, in the AWS cloud, it is referred as NACL, Network Access Control List. As you know that the job of the access control list is to have the rules defined to filter the inbound or outbound traffic or the communication. Talking about the NSG rules, by default, we have 3 inbound rules and 3 outbound rules in the NSG we create. And these rules are created with 65,500, 65,001 and 65,000 of the priority. Higher the number, lower the priority is the concept. Then on top of this, we can create the rules with lower number or lower priority number, which can be between 100 to 4096, anything. And because that number will be lower than these predefined rules, so these rules will override any conflict with the default rules. If you look at the default rules, so there is deny all inbound. So first of all, we block everything inbound, and same rule is there in outbound as well. So as a best practice in access control list is to deny first deny everything and then opening up whatever we want to open. For an instance, in inbound, the Azure load balancer has been allowed, because if my machines are behind the Azure load balancer, then that service must be allowed to contact the virtual machines. That is why this rule is required. Then VNet inbound is allowed from any IP. So within the virtual network, the traffic is allowed from any subnet of that virtual network. Rest, you have to create the custom rules and either allow or block this traffic by using the 5 tuples. This rule includes the 5 tuples, which is the source IP address or can be a CIDR block, and the source port from which the traffic will be originating, the destination IP, the destination port, and the prototype. You can call it protocol type. So these are the 5 tuples that are used. I repeat: source IP, source port, destination IP, destination port, and protocol type. Based on that, I can decide to either allow or deny the inbound or outbound traffic. Security rules in NSG enables you to filter the network traffic that can flow in and out of virtual network subnets and the network interfaces. There are default security rules. You cannot delete the default rules, but yes, you can override them by providing the higher priority. For higher priority, you have to keep the number as lower, which can be 100 to 4096, anything, as I mentioned earlier. Well, this is how the NSG rules or NSG looks like. I'll provide you a demonstration about the NSG also shortly. Let's determine the NSG effective rules, that how do they apply. If I have an NSG applied at the subnet level, then at the NIC level, and I want to allow something, so that allow rule must be present in both of the NSGs. This is where we get the defense in depth. For an instance, if an administrator accidentally allows a wrong port or the IP address at the subnet level NSG, so your entire subnet is not exposed, because the NIC, the network interface card on the virtual machines running inside that subnet, also have another NSG which is still denying or blocking the traffic. So allow rule need to be present in both locations. As you have seen already that there is by default a deny all inbound and all outbound from the internet. So we need to open up the required ports or the IP addresses in both of the network security groups. That is what I was saying earlier, that as a defense in depth architecture, think of applying 2 different NSGs, one at the subnet level, the other at the NIC level. NSGs are evaluated independently for the subnet and the NIC. An allow rule must exist in both levels for traffic to be admitted. Use the effective rules link if you are not sure which security rules are being applied. So effective rules will let you know that what is the final rule that is getting applied. In case you have a complex architecture or configuration and you want to know that on a particular NIC what is the final effective rule that will be applied, so you can do that sort of monitoring, or through network watcher also you can check that whether there will be a destination IP flow or not, or if it is going to be blocked. We can create the NSG rules where we define the source. The source can be IP address, as I mentioned, in 5 tuples. It can be a single IP or can be the IP address range with the help of a CIDR block. Then service tags. We have the service tags for the services that also can be applied. There are service tags for different applications, services that Microsoft offers, so we can use them. We also can use the application security groups, which is nothing but the group of the multiple network interface cards or the servers. If you want the common configuration to be applied on multiple servers and in a dynamic manner, then it is better to create an application security group and group these servers into one. And then in the source or destination, rather than selecting the IP address, choose that application security group. So regardless the IP address of the servers, these rules will be applied. The same is with the destination. The service, we need to decide that whether it is HTTP, SSH, RDP. We have the services mentioned over here within the wizard that helps you to choose the particular service, and its required port or default port number is automatically taken, so that you need not to remember it. Whereas you have the option, always you can go with this custom and put the port number that you want to control. Then priority, the lower the number, the higher the priority is the rule. Implementing the application security group, like I mentioned, that if there are 2 or more than 2 instances of servers which share the common configuration or common rules, security rules, then we can group them into one with the help of application security group. As the name suggests, that the instances of a particular application will be grouped for security reason, the application security group. So that is the purpose. The purpose is logically uniting multiple servers into one group so that we can apply the configuration on the groups. Think of it like we create the group identity or group accounts, and then we add the users as members of that group, users or devices, and then we assign the permissions on the groups. They automatically inherit to all the members of those groups. So it is the same logic here that we use. It extends your application's structure. It provides the dynamism of the dynamic deployment of the rules. ASGs logically group virtual machines, web servers, application servers. As I mentioned earlier, whatever the servers share the common configuration, put them in one application security group, and then use that application security group in the NSG rule. Don't think of application security group as an alternative of NSG. NSG is still required because NSG's job is to allow or block the traffic, incoming or outgoing traffic, whereas application security group is just to group the servers. Define the rules to control the traffic flow. Wrap the ASG with an NSG for added security. Let me take you through a demonstration where I'll show you creating a network security group and exploring some inbound and outbound rules. For this demo purpose, I have created a virtual machine, which is my app server. This app server has a public IP on it, and this app server has been configured with IIS, the Internet Information Service role, the web server role, and this server acts as a IIS server. If I try to access this server through the public IP, I have instance level public IP on this server for this demo purpose, then this server will not be reached. As you notice that the server cannot be connected, and it is happening because the server has a network interface, and that network interface has a network security group associated on it. And the default rule in that NSG is blocking this communication. So if I take you to this network security group, which is app server 1 NSG, you will see that this app server 1 NSG is associated as a network interface, not at the subnet level. You will find the network interface of my app server 1, whereas there is no subnet associated with this NSG. If I show you the 3 inbound rules, so the first rule is to block everything. So you will notice that this rule has been configured with 65,500 number, this priority, and that is to deny all. But then there is another rule with 65,001, which is lower than this one. So that will gain precedence or priority over this one. So lower the number, higher the priority is the rule here. So it allows the Azure load balancers traffic to the virtual machines. That is why it is configured to allow. Next is allow VNet inbound traffic with lower number than these two. Now, if I want to put any rule, so I can add my custom rule over here. Before that, I show you the outbound rules as well. So you will see the outbound rules are almost same as the inbound rules. First, they will block everything, and then VNet outbound traffic will be allowed. But there will be a change in this rule in the center over here. That will be to internet outbound allow. So by default, it allows the internet outbound traffic. But suppose I want to block the internet outbound on this system, so I can configure my custom rule and will give it a number between 100 to 4096, any number, and that will gain priority on top of these default rules and will overrule them. Like this rule, deny rule, will overrule this allow internet outbound rule in this case. I did it to set up the private endpoints in a different tutorial on service endpoint and private endpoints for the virtual networks. If you have not gone through that video and you want to understand the private and service endpoints in Azure, then you can watch my video. Let me go back to this inbound rule because this time it is about the incoming traffic to the server. So because it denies everything and then it allows only the Azure load balancers and the virtual network traffic. That is why from a public network, I cannot get into that server to connect to the web service. Suppose I want to allow that, so I will click on add button. to add a rule, and in that I will click on the source. In the source, it can be any source where from you are connecting, or it can be an IP address or my IP service tag or application security group. I will talk about these rest of them. Right now, I will go with any IP, or if you want to be granular or you want to whitelist only particular IP address spaces, then you can go with IP address CIDR blocks over here for IPv4 or IPv6. Then you can also choose the service tags as your service tags if any service that will connect to this server. So be it your load balancer, action groups, virtual networks, or any service that you want to allow. Or you can use the application security group. I will do a separate video on application security group. Application security group is nothing but grouping of servers. So wherever this application security group is associated, those servers will be treated as the source for this traffic. I will go with any, from any port the traffic may come. It might be through any ephemeral port as well. Those ephemeral port ranges are there in port numbers. So dynamic ports or for randomization, port randomization purpose by the clients that is used. The destination will be any, and then I will go with this service. The service I will choose over here is, let's say, HTTP port 80, and then in the destination I can also choose again the IP address or the service tag or the application security group. I will configure it after this one. Then I will go with the allow, and I will define a priority. You will see the number that you can provide here is like 100, 200, you will give the number this way. So for an instance, I want to create this rule on top of that. So I gave it a number, for an instance, 4000. Allow any HTTP inbound traffic. I will provide the description. Why am I enabling this rule? So allows HTTP from any network. Because in the source network, I have selected any source from any port. Then I will click on add to whitelist that IP address. Now you will notice that as soon as this rule has been configured over here to allow the traffic from any network, and this is port 80 that has been enabled, so source can be any. So if I refresh this, then I will see that web server accessed from my network through this public IP on the server. This rule configuration will take some time to save or to apply. It may take 1 to 2 minutes, so you need to wait for some time. You need to have some patience to test the service. Then once we see this, it will be loading it in a while. Meanwhile, I show you this IIS. I have installed the IIS on this server, but I have not configured this IIS with any particular configuration. So you can do that from the IIS manager, though that is beyond the scope of this program to do this IIS configuration. I will have separate videos on the IIS and IIS servers configuration and many more things about the or everything about the IIS servers. So if you have not subscribed my channel, you can subscribe to it for more videos on this. Well, let this server be accessed. As soon as the rule configuration was saved and became effective, I'm able to access that server, though it is over HTTP port 80, which is unsecure. So I can think of SSL binding and enabling the HTTPS communication. But this was just for testing purpose. Now, in this server, NSG is associated at the NIC level. And at this level, if a network engineer or security engineer configures a rule incorrectly, for an instance, instead of going with this HTTP 443, if accidentally I go with the, let's say, destination service, and this was selected HTTP, I choose this as um, custom, or let me create other one. So what I'm trying to say here is that or if I'm modifying this course, modifying this one, so this is TCP port 80 that I'm using, and if I add a new rule and from any to any, and I open this custom service, which is, let's say, star, so I can open all the ports. So in that case, this server's public IP will expose all the ports. The access control list will allow everything. Okay, it's not only 80 or 443 or 445 or 53, it will open everything. So a wrong configuration of a rule can expose your server. So for the defense in depth, we should apply a network security group at the subnet level as well. For this reference, let me go back to that scenario over here. The current situation you see is that the app server is having one NSG at the NIC level, but because there is no NSG at the subnet level, so a wrong configuration on the NSG at the NIC level can expose this server or the services running on it. So to add additional protection, I will create one NSG for my subnet. So I'll go to the network security groups and create one NSG, and this NSG will be for my subnet. So I'll put it into this test RG, and this is going to be in my test VNet. I have app subnet. So this will be for the app subnet. East US tagging is optional. I will ignore it for this demonstration. Like I always say that in the production it is required for billing purpose, for finding the resources in Azure. This attribute can be helpful in many scenarios. So let me create this network security group for the subnet level protection. And this time, I will associate this NSG at the subnet. How will I do that? I'll go to the NSG and will associate it on the subnet instead of network interface. And then I will associate it here. This is my virtual network and the subnet on which I want to put this NSG. Do not put the same NSG on the subnet and the NIC. Otherwise, the wrong rule configuration in the single NSG will expose both the subnet and the NIC. So have two different NSGs for the subnet and as well as for the NIC. Now, because in this, the inbound traffic is deny all, and then Azure load balancer is allowed and VNet traffic is allowed. So you see that there is an additional protection over here. If you see on the right side that the subnet level NSG will block this traffic coming to the virtual machine this time. So the traffic from any network will come via NSG and then via virtual network subnet, and then will be going to the virtual network interface. So this subnet level NSG will block this traffic here itself, regardless what is configured on the server. So that is what I said, that if you want to allow anything, then you need to put allow rule at both the levels. If I try to access it, it might access this page from the cache. Let me launch the incognito window and try to access this public IP. You will notice this IP will not be reachable because the subnet level NSG will block this. Well, if I want to open this IP address or traffic to this IP address from any network, then I will have to configure a rule at the subnet level NSG as well. So I need to create an allow rule here also. From any network, from any port, the traffic is coming and destination will be the custom port, or let's say it is HTTP port 80, and TCP allow and then the rule priority, so 4000. If you will give next rule number over there, then rather giving 3999, give 3990. Keep some scope of, let's say, at least 10 numbers in between, 9 or 10 numbers, so that you can add more rules in between if required in future. Now I will say allow HTTP 80 port 80 and from any network to this subnet. Now the subnet also has a rule. So last time I got disconnected, I was not able to connect to the server because the subnet level NSG was blocking it. This deny all inbound was blocking it. But now I have opened port 80 from any network to any IP address. It's not a particular server. So to all the servers in this subnet, I have opened it. And then this rule will allow, and I have the allow rule at the another NSG as well, which is server level NSG. So both NSGs will allow the traffic. Here we go. If I show you this app server level NSG, and there is also the allow rule, and that is the reason that I'm able to connect. So if you open any port over here accidentally, so users will not be able to connect until you add that rule in the subnet level. Suppose at this NIC level, I go with the RDP 3389 and I allow the RDP 3389 over here, and the number I'm giving is, let's say, 3990, and then allow RDP inbound port. So this rule has no relevance until and unless I configure the same rule at the subnet level NSG as well. So this is about setting up the NSGs on your virtual subnets and the virtual